Welcome back. This is the fourth video in this series, and we're almost done taking this thing apart. A quick recap before we begin. The first episode was mostly just a survey of the computer and the plan for the project. The second video covered the user port fix, and the third involved disk drive maintenance. So in this episode, I'm going to remove the I/O and CPU boards, put on some heat sinks, and fix yet another design flaw in the SX. Things will really start to get interesting, though, in the next episode when the rebuilding begins. Let's start here with the expansion board. It's a bit weird that this sticks up from the top on the SX, but it's where they had room to put it. There is an issue with the expansion board, not exactly with the expansion board. Some cartridges seem to lock up on the SX, even though they run fine on a regular 64. You can read more about this on Ray Carlson's site, which I'll link below. The problem seems to be basically that the SRQ, the serial request line, gets stuck trying to talk to the CIA. The solution is to add a resistor between a 5-volt source on the keyboard connector at P12 and the serial connector at P11 here on the I/O board. I'll do that in just a minute, but first I need to get this expansion board out of the way. I just need to remove these two screws and then unplug the ribbon cable underneath. I think actually I'm going to leave that on there for a minute because that's kind of hard to pull off of there. Now I'm going to remove the I/O and the CPU boards. The I/O board is already only held on by this connector. Let me go handheld for a moment here. This connector right here. There should be another little black pin holding this corner in place, but that's already been removed. So now I could just pull this board free. Instead of doing that, though, I'm going to take the CPU board and the I/O board out together. With everything unplugged, it's just easier than trying to yank sideways on the I/O board and maybe damage the pins. Now the CPU board is only held in by more of these black plastic pegs here, and over here in this corner as well. So I'm just going to push those in from the back and then use my chip puller with the handy little notch to pull them out. It's already coming a bit loose. Now, before I lift this out, I want to point out one thing. If you look down here, you can see, let me go handheld for a second again. This chip down here is the 6510 processor. Ordinarily, I would like to have a heatsink on that. But because this bundle here is the keyboard cable, there's not really room to put a heatsink on here. And if I tried, I'm afraid either the keyboard cable would end up just knocking it off and I'd have something loose rattling around, or if it got hot enough, it could potentially damage the insulation on the keyboard cable. I don't know if it would get that hot. But regardless, there's just not really a good way of putting a heatsink on that. So that's one chip that's not going to get a heatsink. Okay, now before I pull these boards out, I need to take off the keyboard connector as well. Thing is on there tight. Just trying to support this with my thumb so that I don't bend any of the pins as I'm wiggling this out. Okay. And now I should be able just to lift them out. Got a wire caught back here. All right. Now that the boards are out, I can pull off the expansion board easier. Alright, so we have the I/O board here. You can see it's dominated by the two 6526 chips. This is interesting. It looks like one of those has been replaced. The date code on this one is 0384 and it's a standard 6526. The date code on this one is 20 of 88 and it's a 6526A. Looks like that chip has been replaced at some point. A couple other things to note on here. There's some standard logic chips. You've got the crystal, the 556 timer chip here. Pretty much that's about it. Now you can see that it's only held on to the CPU board by this connector here. Make sure you can see that. I'm not sure why Commodore didn't just use a ribbon cable or something. Maybe it was a question of data transfer speeds. I'm really not sure. But this is a source of many issues with SX-64s because these boards can wiggle loose, especially if you're moving them around a lot. I do have a fix for that, which I will show you when I start reassembling this thing. For now, I'm just going to pull them apart. Okay, with the boards out, let's take a look at what we've got here. Talked about the I/O board already. Here on the CPU board, you've got the RAM chips here on the left. You got your CPU right here, the 6510. These three ROM chips, top to bottom, are the character ROM, the kernel ROM, and the basic ROM. Okay, and we've talked about how the kernel ROM here is an EEPROM. We've talked about that in a previous episode. Here's the SID, and here's the VIC-2 chip underneath this heatsink, which is held on with these clips. Now sometimes these clips could possibly come off. The heatsink could come off. I don't think I've ever seen an SX-64 where that has actually happened, but I've heard that it could. So that's something you want to check on. Now I would normally put heat sinks on the processor and the SID chip, the VIC obviously, but it already has one. Because, as I mentioned a minute ago with that keyboard connector, we can't really put one on the processor. So we're not putting a heat sink on that one. And I would put one on the SID, but I'm actually going to be removing that later as one of the mods. So I'm not going to bother putting a heat sink on the SID either. Which means that the only chips getting heat sinked will be these two CIAs on the I/O board. Okay, so here are my two aluminum heat sinks that I'm going to be putting on. And in order to do that, the first thing I need to do is make sure the chips are clean, so I'll wipe them down with some isopropyl alcohol. Okay, so I have cleaned off both of the chips. I've cleaned off the undersides of the heat sinks. Now it's time to put them on. And there's a few different ways of doing that. You might use something like this, which is a thermal joint compound. And what this does is it assists in heat transfer between the chip and the heat sink. Now, the joint compound here is a little bit sticky, but it's not like glue. So it won't hold the heat sink in place by itself. So you would use this where you have also some kind of mechanical way of fastening the heat sink to the chip. So for instance, in the SX-64, the VIC chip has that heat sink that's held in place with those little clips. Another place where we find that on Commodore machines is here. Now this is a board from a 128, and the metal shield on the top here is an RF shield, but it doubles as a heat sink. See, all these little tabs that come down actually touch onto the chips underneath that get the hottest and need to have heat sinks on them. So they come down, they press onto the chip, and then the whole metal shield acts as a big heat sink. So underneath this shield, I've removed a lot of chips. This has become kind of a parts board. But underneath on all of these tabs, you would put some of that joint compound to help the heat transfer from the chip into the heatsink. Another option is thermal glue. Like the thermal joint compound, this helps with heat transfer between the chip and the heatsink, but this is actually a glue. So it will glue that heatsink onto the chip and it will hold it there by itself. And this is what I'm going to be using. There is another option, which is thermal tape. This is just a double-sided tape that has been designed to also transfer heat efficiently between the chip and the heat. Now, I do this all the time when I'm heat sinking chips in my desktop unit. So if I'm going to put a heat sink on a 128 or a VIC or a regular 64, I'm going to use this because it makes a lot less of a mess. And if I ever decide to take that heat sink off, let's say the chip fails or whatever, it's a lot easier to pull it off with this than to get it off with when it's been glued on. The reason I'm going to use the glue on the SX is because I anticipate the SX being moved around a lot more, and I just feel like the glue is going to hold it in place better, given all that jostling around. I'm sure the tape would be fine, but yeah, something just tells me to go for the glue. Okay, let's do this. All right, so I'm wearing a glove for this just because I don't want to get this all over my hands. It's not going to hurt you or anything, and it actually cleans off really easily. It's just, I don't want to get it on my fingers. So I'm going to take this, and I'm going to put a little bit here on the chip. Don't need a huge amount. Then I'm just going to kind of wipe it on with my finger. That's probably actually a bit much, so we're going to put some here on the other chip. Tad bit more. I want to make sure these capacitors and stuff are out of the way. Okay. And then just sit the heat sink on there. Press it down. Don't even have to press all that firmly. You just want to make sure that it's on there solidly. Do the other one. And you can see I'm not pushing down very hard on these, and I'm not holding them on there for a really long time or anything. That's plenty good enough. Okay, and you can see you can still kind of reposition them for a little while. Now this stuff does take a while to cure. I don't know exactly how long it takes. There's no directions that came with the tube, but I typically, once I put it on, I typically just put this aside for 24 hours just to be on the safe side. Okay, so the heat sinks are firmly attached to the CIAs. Next, I'm going to add that resistor I mentioned earlier. This is a 3.3K resistor, and it's going between pin 4 on P12. This is P12, this is the keyboard connector, and pin 1 on P11, which is the serial connector. Here's a photo that shows those pins a little bit better. You can see that they are numbered. At least we get numbers 1 through 6 for the serial connector, and we have numbers 1 to 12 and then 13 to 24 for the two different rows of P12, the keyboard connector. Here on the back of the board, I've marked both of those pins with a red Sharpie. I like to do that when I have to get to a specific pin, because it just makes it easier to find once I've got the soldering iron going and other things in my hand. It's just easier to look at it and see that red dot and know exactly that that's where I'm going to. And the Sharpie comes right off with a with isopropyl alcohol, so there won't be any marks left behind. So all I have to do is stretch the resistor between those two pins. Alright, so you can see there's plenty of room here. The leads on the resistor are plenty long. So I want to put it kind of in the middle. Okay, so off camera, I soldered one leg of the resistor onto pin 4 of the keyboard connector at P12. That's the 5-volt power source. And the other end of the lead is going to go onto pin 1 of the serial connector at P11. This is the SRQ line. So what I need to do first, though, before I solder that down, if you look at it, you can see where those leads are going to be very close to touching those exposed pins. So before I solder that down, I need to put on a piece of shrink tubing to prevent any possible short circuits. Now I can just lay this down. I'll bend that pin over and solder it down. Okay, that's on. Now I don't think that shrink tubing is really going to go anywhere, but just to make sure, I'm going to touch it here with the end of the soldering iron just a little bit and just kind of shrink it down. Okay, that's good enough. I don't want to do it too much because, one, it really stinks. Two, I don't want to burn it. Okay, so resistor is on. This part's done. Okay, so we need to remove the rest of the components in this case. First thing to remove is the CRT and speaker unit. And that's actually pretty simple. It's held in by 4 screws, 2 on each side. So if I remove all 4 of those, that whole unit will just lift up and out. But I can't do that yet because this bundle of wires that connects to it runs over here and goes through 2 plastic clips, one there, one here, and then it runs into the front side of the control board. Here and then down lower is another connector. Now I can't remove those wires unless I either remove the control board or I remove the front faceplate. I can't remove the control board without removing the front faceplate, so I have to remove the front faceplate. How's that done? Well, there are 2 screws on each side, one here and one about here. So in order to remove the faceplate, I've got to remove the bottom cover first. Okay, I've removed the screws holding the bottom case on from the side, but there are more. There are screws here, one in each of the 4 corners, that hold the feet on. And they go all the way up through into the inner part of the case here. So I've got to get all 4 of those off before the bottom part of the case will come off. And finally, there is one more screw right here that needs to come out, and then we can take the case off. And now we can finally remove the faceplate. Okay, now the faceplate is loose, but it has a little ridge on it that sits in a notch on the other side of this plastic piece here. So to get the faceplate off, we have to kind of be very careful here and just carefully kind of pull it out of there. Just like that. Okay, here's a good look at our control board. You can see the 2 screws that I have to remove. I'll do that next, and then pull the wires up out of those plastic clips, and then unscrew and remove the CRT and speaker unit. With all that done, here's the final removal. Well, here it is out of the case. You can see it's in really good shape. You know, everything worked. You saw that in the first video. It's just so heavy. I'm looking forward to getting the LCD screen in there. And that will come with its own control board, so I don't have to do anything with this control board. It'll just stay here with the rest of the unit. Yeah. The only thing that I might have to take off, and I don't know this yet, is this red and pink wire here is the wires for the drive reset. And I don't know if the screen is going to come with a wire that will run all the way back to the drive board or not. So I might have to take that off, or take the end of it off or something at least. I don't know yet. We'll have to see. For now, this is going to get packed up very carefully, very well, and go into storage. And finally, the only thing left in the case is the keyboard cable. So that's easy. 2 screws here, the grounding screw here, and then there's another screw here. We'll remove those, and that will be it. Well, there you have it. A very bare, one might dare say naked, SX-64 case. I'm going to clean this thing up, and then I'm going to clean the case parts, and we'll start putting this thing back together one little piece at a time. But that's for next time. Thanks for watching.